Hello students, today we are going to discuss about this chapter called as force and pressure. And first we'll try to understand what is force. Then we'll go to the topic pressure. So here the definition of force is given over here. So this is the definition of force. So when a push or a pull is applied to an object, it is called force. So this is something which we do on our day-to-day life. Sometimes we push certain things, sometimes we pull something. I'll show you the example for that, then you'll get a better clarity about it. So any kind of push or pull is called as force. Okay, and the next thing is a force can change the state of an object from rest to motion. That is, if something which was in the position of rest, it was not moving, by applying a force we can move it, or if something was moving we can stop it with the application of force. So here I'll show the example, then you'll get a better understanding about it. So here you see in the first diagram, as you can see, there's a goalkeeper who's stopping the ball. So the ball was in some motion, it was moving, but it was stopped by the goalkeeper. So the state of the motion of the object has changed here, right? So this is an example of force. Next you can see with the hockey stick, the player is playing the ball, hitting the ball. So he is moving the ball over here, right? So this is also a force. Then you see a fielder who is fielding over here. Like that, there are so many examples of force that we see on our day-to-day life when we push something or we pull something. Okay, so some of the examples of force I have shown over here. Next we'll see what are the characteristics of force, or we can say what are the properties of force. So when two forces act on the same in the same direction, the net result of the force on an object is the same of these two forces. So what does it mean? So it means here that you see there are two person and they are pushing this box in the same direction. Both are applying the force in the same direction. So when we apply the force in the same direction, then the resultant force, so resultant force we can also call the total force, because now it's not just the force of one person. One person is applying some force, the other person is also applying some force. So the total force of both will be added up, and that will be the total force or the net force which will be acting on this body. Same way, if in this case, in the other case, if you see in the second diagram, see these two person are applying the force in the opposite direction. So this person is applying the force in this direction and this person is applying the force in the other opposite direction. So when we apply force in the opposite direction, what happens is the net resultant force or the total force, here what will happen is it will be the difference of two forces. For example, this person has applied say 100 Newton, this is the unit of force, and this person has applied say 80 Newton of force. Okay, so what will be the total force acting on this, and how much of displacement will happen will depend on what is the total force. So here what will happen, since they are opposite to each other, so the net force will be, it will be 100 minus 80, that is equal to 20 Newton. So just 20 Newton of force applied here, because there are forces acting in the opposite direction. Whereas in this case, if this person with the yellow color shirt is applying 80 Newton, okay, and the other person is applying 100 Newton, so here the force, the net force adds up over here. So we'll get 100 plus 80 over here, that's 180 Newton. So you can see the difference between when force is applied in the same direction and the force is applied in the opposite direction. This is one of the characteristics of the force. Similarly, there are some other properties also, like the force always has a direction in which it is applied and the measure of its strength or magnitude. So what does it mean? I have to go back to the previous diagram. So you see here they are telling that there are two components of force. One is called as the direction and the other is called as the magnitude. So what does direction refers to? Now they are applying the force along this direction, so this is the direction of the force, and the magnitude is how much of force they are applying, that is called the magnitude, or the strength of the force, with how much of strength they are applying the force, that's called the magnitude. So remember that we have direction as well as magnitude of force. Now a person, an adult person who is strong enough, so if he applies some force, the force will have higher magnitude. Whereas if there's a small kid and the kid is also applying the force, so obviously he have less strength, so his magnitude will be less. Next is, the effects of a force may alter when the direction of the magnitude of the force is changed. So what does it mean? That is, sometime by changing the direction of the force, okay, by when the direction of the magnitude of the force, so this basically means the direction of the force. If you just skip this word also, when we change the direction of the force, the effect of the force also may change. Okay, what is the intention of the force can be changed by changing the direction of the force, right? For example, we have to go to, I can give the example of magnetic force. So by changing the direction of the magnet, of the poles of the magnet, we can get different effects, so that we'll discuss later. Okay, but you can understand, by changing the direction of the force we can change its effect also. We can sometimes cause attractive force, sometimes we can call it repulsive force. So that more in detail I'll discuss when I discuss about the other non-contact forces. Okay, so that time we can discuss about it. Next is, the effect of more than one force being applied on an object is calculated by evaluating the net force acting on the object. So this you see here in this diagram, you see there are two people applying the force, right? So there is more than one force, there are two forces over here. So the total force over here can be calculated by adding, if the force are in the same direction, if the force in different direction, we'll subtract it. There are different reason behind that, I explained you already. Okay, but anyway, it's calculated. Okay, it's calculated when there is more than one force, the calculation is done as net force. Is done as net force. Net force means if there is more than one force, then the total force that we consider over here, right? Okay, so that's what given here. Evaluate, so calculated by evaluating the net force whenever there is more than one force. Next is, if two forces are acting upon each other having equal magnitude and in opposite direction, then the net force acting on the object will be 0. Okay, so you just see here there's some keywords over here. If two forces acting on each other have equal magnitude means they have same values. For example, one has 100 Newton, the other one also has 100 Newton. There are two different forces, both are 100 Newtons. Okay, and they're in opposite direction. Opposite direction means the direction is referred as plus and minus. So any one direction which you consider is along your direction, that's your direction, along the direction. Okay, so that's considered to be the positive direction, and something which is opposite to your direction, that's taken as the negative. It depends on the situation. For example, here you can take this force to be the positive. So if this force is taken positive, this based on its direction, then the opposite one, this I'll take as negative force. And now if I say both are applying the same force, imagine that this person is also applying 100 Newton and this person is also applying 100 Newton. So here the net force, whenever we have equal, see the values are equal, but the direction is different. So in this case what will happen, plus 100 minus 100, that becomes 0. So here the force will be 0. Okay, so remember this, whenever the force have equal magnitude but opposite direction, okay, the direction is shown by the sign, plus or minus sign. Okay, so then they cancel out and the net force is 0 in that case. Force, next point is, force can bring different changes to the object's position, size and shape. So it can change the position of the object, it can change its shape and size, as you can see over here, effect of force I have shown. So here you see this, there is a trolley. So this trolley, okay, when we apply the person is pushing it, so the trolley is going to change its position constantly, right? So this shows the change in position. And here you can see the change in shape of the object, as there is a rubber band. If you just stretch, you can stretch the rubber band. Okay, you can press a sponge, okay, or you can squeeze a spring.